Okay, here's the second part of your video, and now we're going to talk about compound inequalities, which are a little bit more difficult than regular inequalities because obviously they are compound, which means there's going to be two inequalities that we're going to be looking at one time. So there's two cases that could happen here. This is called a union. You might remember it from geometry, and this guy is called an intersection. And union is an or statement, which it puts everything together, and an intersection is only what they have in common. So those are the types of inequalities we're going to look at for the compound inequalities are or and ands. I do have some life hacks to help you remember this as we go on. Okay. So first of all, we're just going to practice looking at no solutions. I actually think this slide probably belonged up there, which is kind of a sad thing, but this is fine. We're just going to pretend that didn't happen. I am going to put back where it belongs for later, but okay. Which one of these have no solutions? Is x greater than x? Well, if you get your x's together, you end up with 0 greater than 0. Is that true? Is 0 bigger than 0? No, that's false. That is no solution. No solution. How about this one? Negative 3x less than equal to negative 3x. Get your x's together. So add 3x, add 3x. Once again, you get 0 less than equal to 0. That is a true statement. That is always true. That is all real numbers. That is infinitely many solutions. So not that guy. How about this guy? Get your x's together. If you subtract your x's, you get negative 4 is bigger than negative 2. How do you feel about that? Is negative 4 bigger than negative 2? No, that's a big fat lie. That is not true. So that is no solution, which is what I'm looking for. That has no solution. And then this guy, x minus 2 is less than x plus 3. Get your x's together, and you have negative 2 is less than 3. How do you feel about that? That is true. When's it true? It's always true. That's all real numbers, infinitely many solutions. That's not no solution. Okay, so there was that. That was a little refresher reminder. I might figure out how to edit the video if I have time. We'll see. Okay, here's the compound inequalities. So a compound inequality is 2, and you have either or and. So for x to be less than 5 or x is bigger than 11, they both can't be true at the same time. You can't have a number less than 5 and bigger than 11. That's really difficult. So when you graph this, you graph them both on one piece of graph line or number line, and you have 5 here, you have 11 here. So x is less than 5. It can't be 5, so we're going to do an open circle. It's all these numbers, like 0 and 1. Or it's bigger than 11, which is this. It can't be both. There's no numbers that would have both. So what I tell kids is if it is an or statement, when you graph it, it kind of looks like oars of a boat. Like, you know, row, row, row your boat. Like if I draw the boat in here, like you can't see me. I'm rowing a boat. So if you think of oars, and then if you think of the U for union as that boat, those are union statements. Okay. This guy here, this is an and statement. X is greater than equal to 1 and less than 7. So you have 1 and you have 7. It's bigger than and equal to 1. So it's 1 and bigger and less than 7. So both have to be true. So this intersecting area is what would make them both true. So this is your solution set. You can write it with a square bracket 1 to 7 with a parenthesis if you want to. That's that set notation. We're going to kind of start learning about that a little bit. But this is an and this is kind of stupid, but I said it kind of looks like this, like the profile of a sandwich and has and in it. That's a stretch. I know that's a stretch, but that's how you can remember what that graph looks like. Okay, so ors have the boats and ands are like the sandwich. Okay, so we're going to do this guy. Solve and graph the compound inequality. It's an or, so I expect my graph to look like the oars of a boat. And we just solve them both separate. So I have negative x minus 5 greater than or equal to negative 2. We're going to get the x by itself, so we'll add 5 first. Negative x greater than or equal to 3. Okay, we're going to divide both sides by negative 1, and we're going to be really careful because when you multiply or divide by negative, you do have to flip the inequality sign. So x is less than or equal to negative 3. You look at the second friend here, 3x plus 15 greater than 21. Subtract 15, and you get 6. So 3x is greater than 6. Divide both sides by 3. You don't have to flip it here because it's a positive 3. And x is greater than 2. It's an or. So they are going to be like oars of a boat. Negative 3 is smaller. Solid circle to the lefters. 2, open circle, shade right. Look, oars of the boat, row, row, row your boat. If you were to write this with that interval notation we talked about, I don't anticipate you having to do this. You'll have to do it next year in Algebra 3 if you take it. The graph tells you what you're looking at. You're looking at negative infinity, and then it stops at negative 3. Negative 3 is a solid, so we put a square bracket. Then we put the union, because remember the boat goes in here. And then 2 is an open parenthesis because it can't be 2, and it goes all the way to infinity. And infinities always get parentheses because you can never get to infinity. Okay, moving on. Did I just do that one? All right. Which one of these graphs is right for this guy? Well, it's an and, so this is the or one, so this is out. So hopefully you got rid of that right away. So now you just got to figure out what the n values are. So let's just look. Negative 2 is less than 2x minus 6. Okay, let's add 6. 4 is less than 2x. Divide both sides by 2. And I get 2 is less than x. If you want to write it the way, so the x is on the left. Remember the alligator mouth is eating the x. X is bigger than 2. Okay, so right away I know which one is the answer because this one is in the negative range for the x is greater than, so this is it. I can stop right now. I don't even have to work that other inequality. Okay, now these are more word translation things. Obviously, what do you got here? Sum, addition, less than, more than, at most, at least. That means it could be equal. Okay, so all these words are phrases that we're going to have to translate words into expressions or equations. So I think we're going to have an example or two of that. All right, oh, Monique, that's nice. All right, so she makes $11 an hour delivering pizzas. That's decent because she probably gets tips too. She works Monday through Friday, and on average, she earns $20 a day in tips. So if Monique made no less than $4.50 for 1 week, find an inequality for the number of hours she worked. Okay, so what are we looking for? We're looking for hours she worked. So we're going to say H is hours. Okay, so we're talking about how much money she makes. She makes $11 per hour. So that would be 11 times the H. How much more money does she make? She makes $20 a day in tips. So am I going to put plus 20 here? Not really, because we're talking about for a week. So it's $20 a day. She works Monday through Friday, so there's 5 days. So she's making $100 in tips. So 11H plus the $100 average in tips she gets. And she makes no less than $4.50. So $4.50 is here. So this is not less than that. So this is going to be bigger than $4.50. Could it be $4.50? It's not less. Could it be equal to $4.50? I don't know. Let me think. No less than. It could equal it. So that has to be greater than equal to $4.50. I always have to talk myself through those. I think they're tricky. Okay, and I think this is our last one. A ball is thrown down from a balcony with a vertical velocity given by this. Choose the inequality that represents the time for which the velocity is between -90 and -58. Okay, so here's the equation. They want -90 and -58 for it to be between there. So you will go with the smaller number on the left, and it is negative. So -90 is the smaller number, and then -58 is the bigger one. And you'll put your equation in the middle. If it's between it has to be bigger than this guy. So the equation has to be bigger than the -90. And it has to be less than the -58. It has to be between there. So you're looking at this friend here. Now they want you to graph it. You can separate this into two separate equations, -90 less than -32t minus 10, or -32, it's not an or at all, it's an and, -32t minus 10 less than -58. And it looks like you don't have to solve both of them. You know it's not this guy because it's going to be an and, so it's got to be one of these. So you can pick the one you want to solve and see because it's multiple choice here. If we add 10, -32t less than -48, divide by -32, it's kind of garbagey, isn't it? So t is going to be less than -48 divided by -32. I'm typing it in my calculator. -48 divided by -32. 1.5. So t is less than 1.5. So we're looking at this guy. Oh, it doesn't look like t is less than 1.5. It doesn't look like it's greater than it. Oh, doggers, what did I do? Look, guys, I made that number one mistake. I told you. I divided by negative and I didn't change it. See, even your teacher makes mistakes. Actually, I was just testing you. I didn't really make the mistake. I caught it. So we switcheroo here. X is bigger than 1.5. And that is the correct answer. You got to be really careful about flipping that inequality so you're not an idiot like Mrs. Bruno. Okay, that's it for 1.2. And there will be a Google Doc for you for your homework.